Hi guys, and welcome to the Physical Sciences for Year 10. In this video we're going to be looking at the concept of acceleration. So previously we looked at speed or velocity, and we knew that speed and velocity is distance over time. Velocity obviously having a direction linked with it as well. Now acceleration could be classified as a scalar product or a vector depending whether direction is being included. But firstly we need to understand what acceleration actually is. And basically acceleration is a change in the velocity over a certain amount of time. Now we learned from our speed and time graphs that basically as the speed, if the speed on a distance time graph is basically straight, then we've got a constant speed. However, if it curves, it means that the speed is continually changing. If it's continually changing, then we've got an acceleration. So the greater the change in velocity that we have, the greater the acceleration. And likewise, if it happens over a short amount of time, we're also going to get an increased acceleration. Now acceleration basically can be written as a mathematical formula, and the mathematical formula is shown below. Now here we have A equals delta V over t. Well, delta V just stands for a change in velocity. It's the final velocity minus the initial or the starting velocity. Now the final velocity is given the symbol V, and the initial or starting velocity is given the symbol U. So what we're saying is, what did we start with and where did we finish with? Now if where we finish with is greater than where we start with, we'll get what we call a positive acceleration. That's why when you put V minus U, V will always be bigger than U, so it comes out as positive. It means you're getting faster. Likewise, if V is smaller than U, if the final velocity is less than your starting velocity, then obviously you're slowing down. That means it's a deceleration. Now, the formula works really nicely again in a triangle, and you can use the triangle to cover up the one that you want to find, and then as a result you can find your unknown. Now, you cannot use V minus U in this triangle. You always have to find the change in velocity first and then use the triangle afterwards. So, let's just recap. Acceleration is the change in velocity over time. So, the change in velocity is basically delta V, where V is the final speed in meters per second, U is the initial speed in meters per second, and time is obviously the time in seconds. Now acceleration is basically given the notation meters per second per second. Meters per second is the velocity or the speed per second. So how is the speed changing per second? So as a result you get m/s or ms to the negative 2. Either notation will do, but you do need to be able to recognize them. And as I stated earlier, if we have a positive acceleration, it means that we are accelerating. If we have a negative acceleration, we state we are decelerating or we are slowing down. Okay, so try and become familiar with these symbols and their units and the formula. Remember, you'll get the first formula on the left-hand side at the front of your paper. The rest you're going to have to learn and be able to apply. So let's have a go at a couple of examples. So here we've got to find the acceleration of an object which changes from 3 meters per second to 6 meters per second in 2 seconds. So you notice that we're getting a change. We're increasing our speed from 3 meters per second to 6 meters per second, and it's taking 2 seconds. So what's our change in speed? What's our acceleration? So again, write down what you know. Well, we know that our initial speed or our starting speed was 3 meters per second. Our final speed, which is we classified as V, is 6 meters per second. It takes 2 seconds to do this, and we're trying to find our acceleration, which means we can use the formula delta V divided by t. Remembering that delta V is the change in velocity, the final minus the initial. So now we need to look at our conversions. Well, there are no conversions that we need to calculate in this, so all we need to do is to calculate our change in velocity. So change in velocity, or V minus U, is 6 minus 3. So the change in velocity is 3 meters per second. So instead of delta V, I can put 3 meters per second. So now I can do my calculation. So let's write down the formula. A equals delta V over t. I know that delta V is 3 because I've just calculated it, and I know the time it took was 2 seconds. So it's 3 divided by 2, which is 1.5 meters per second every second. So that means that the speed increases by 1.5 meters per second every second. Okay, let's have a look at another one. In this case, we're finding an acceleration of an object that is travelling through 23 meters per second and stops in 5 seconds. So let's write down what we know. Now, we've only got 2 numbers there, so alarm bells sort of go off in the back of your head, but the thing to understand is it states that it stops. So that means if it stops, its final speed at the end of the journey was 0 meters per second, which means that we can write down V as 0 meters per second because that's our final velocity. We know we started at 20 meters per second, so that's U. So we started at 20 meters per second and we came to a stop, and it took 5 seconds for that to occur. So we're going to get a deceleration here. We're going to be slowing down. So we still use the formula A equals D over T, delta V over T, and we'll look for our conversions. Well, again, there's no conversions, but I can calculate delta V. So let's just substitute in. We know that our final velocity is 0, and we know that our starting velocity, or U, is 23. So I use the formula V minus U, so that's 0 minus 23. Now the minus 23 meters per second, the minus value just means that it's slowing down. It's a negative acceleration, which we discussed in the first slide. So don't worry any more than that. All you just have to say is that it's slowing down. So now we can do our calculation to see what the acceleration is. So A equals delta V over T. We know that delta V is minus 23, and it took 5 seconds to occur, which is 4.6 meters per second. Again, the minus just shows that it is slowing down or is decelerating. It's a vector, so as a result, we've got this idea of direction again. Okay, so that means that the speed is slowing down by 4.6 meters per second every second. Okay, let's look at a final example. In this case, we're going to have to do some rearrangement. We're going to find the starting velocity of an object which accelerates at 12 meters per second for 4 seconds to reach a velocity of 6 meters per second. Now it sounds complicated, but all we have to do is to write down what we know first. Well, we know that the acceleration is 12 meters per second. We know the final velocity ends up at being 60 meters per second. We know the time is 4 seconds, and we've got to find U. So we're going to use A equals delta V over T. So let's look at our conversions. We've got no conversions, but we can basically substitute in for delta V, because we know that V, our final velocity, is 60. Now we don't know U, so we get 60 minus U. So we can substitute that into the formula. Alright, so here we go. A equals delta V divided by T. So all that means is we're now just going to substitute in for all the values. Keep everything simple. Don't try and get clever and start rearranging straight away. Just substitute what you already know. So what we're going to do is we're going to say 12 equals 60 minus U divided by 4. Now the 60 minus U goes in brackets. So obviously what we're going to do is cover up the delta V to get the equation delta V equals A times T. So we can now rearrange it, so we get 60 minus U equals 12, which is the acceleration, times V, which is the time. There's our formula. So now it's easy. Multiply the 12 and the 4 together to get 48, and take the 60 to the other side and minus it. So I get 48 minus 60, which is minus 12. So minus U equals minus 12, which means that U, positive U, must equal 12 meters per second. So it means that it started at 12 meters per second, it accelerated at 12 meters per second for 4 seconds, and as it increased, it got to a final speed of 60 meters per second. Okay, well I hope you found that useful. Do go through and watch them again and practice, and if you follow the procedures, you can't go wrong. There's only a certain amount of questions that can be asked there. Now we could do exactly the same for this example to find the final velocity if we were given the initial, the acceleration and the time. So it's just the same sort of process, so don't get worried. Okay, well thank you for watching, and what I'd like you to do now is have a go at some of the acceleration exercises on 1.7 of chapter 3, or have a go at the acceleration problems, which you'll find as a Word document on the iTunes U course. Okay, thank you for watching.